Hey everyone, and welcome to the Chaos Studio demo for Microsoft Build 2024. My name is Nikhil Kaul, and I'm a product manager on the Azure Chaos Studio team. I'm excited to be able to speak with you. Today, we're going to be talking about resiliency principles for building on Azure, as well as chaos engineering best practices, use cases, and getting started with using Chaos Studio and getting value out of resilience validation in Azure. Without further ado, let's get started. So as you all are probably aware, since migrating to the cloud, application development has become fairly complex in terms of being able to build applications that are resilient and capable of being able to handle disruptions and recover from them accordingly. What this means is that we really have to think of new strategies for building resilience into our applications, given that you, as the customer, no longer have direct control over, for example, fixing an outage in your own data center when it happens. Hence, building resilient applications and validating that those applications are resilient using products like Chaos Studio is more important than ever. More generally, implementing quality practices like chaos engineering throughout your development lifecycle, from testing all the way to production, is really the best way to feel confident in the resilience of your application built on Azure. Azure believes that building reliable systems is a shared responsibility. It's not solely the responsibility of Azure as the service owner, nor you as the customer of Azure and designer of your cloud infrastructure. The way we like to frame this shared responsibility is that it is Azure's responsibility for the reliability of the cloud, meaning the resilient foundation upon which the core Azure capabilities are built upon, and making sure that that foundation is designed, operated, and monitored in a way that is reliable from the ground up. This involves using chaos engineering as a service. However, customers are empowered to build cloud infrastructures of all shapes and sizes to fit their specific needs. This means that it is the customer's responsibility for ensuring that their app or workload and the architecture of the infrastructure built underneath it is built in a highly resilient and available manner, which enables disaster recovery, high availability, and backup. So what is chaos engineering? Chaos engineering is the practice of using a hypothesis-driven approach to finding design improvements to your system using systematic, controlled chaos experiments that you use to learn and improve your systems by simulating real-world outages. The way you should think about chaos engineering as a principle is that you start from the assumption that things will fail. And you know things are going to fail. Ask yourself, how do I design my infrastructure in a way to be resilient against such failures, given that they are inevitable? To do this, we use an approach that mimics the scientific method. We define a hypothesis for how our system should behave, build an experiment to test said hypothesis, ensure that our monitoring and analytics tools are in a place to validate our hypothesis or disprove it. Then, finally, we use the learnings to improve the resilience of the underlying infrastructure for our application or workload. What we really want is to be able to analyze our system, create new resources and tools based on this analysis, and then drop those into our infrastructure in order to make sure that our systems are resilient and available. So what are some common use cases that organizations find value from using chaos engineering as a service? There are a variety of different scenarios which we see customers use our product for, such as doing ad hoc experimentation in your dev test environment to validate certain hypotheses or assumptions, testing your on-call process and monitoring training and validation processes to ensure that your people resources react and respond appropriately in high-pressure outage scenarios, augmenting your system stress and integration tests that you are already doing, enhancing your CI/CD pipeline automation and gating new code check-ins using chaos experiments to reduce the number of regressions happening later in your pipeline, reprogramming past incidents to ensure future resilience, simulating drill events or game days to validate disaster recovery and business compliance scenarios, performing continuous production validation throughout the entire lifecycle of your application development process, and even performing tests in production environments themselves. What are the critical elements of running a chaos experiment? Well, a chaos experiment has a variety of pieces that make it an orchestration tool for simulating real-world scenarios. The first building block is your application, built on Azure, and that application being deployed to an environment appropriate for your maturity with chaos testing. The second element is the Azure resource which you are targeting, which your application relies on, the underlying infrastructure of your application. Then, another important element that we like to really emphasize is having synthetic workload or real customer traffic to represent what a real-world scenario would look like. You don't have outages with nobody using the service. So we have a tight integration with Azure load testing for you to start and stop load testing directly from a chaos experiment. Another critical element is making sure that you have proper observability, so that when you run your chaos experiment, you can actually have clear monitoring of what your SLIs and SLOs are showing. Are you meeting your customer expectations? Your business expectations? Are you seeing all the right telemetry? Is your hypothesis being validated or disproven? All of that comes from having good observability in place. Chaos Studio supports being able to stream logs and audit logs to a log analytics workspace, event hub, storage account, or third-party monitoring tools, as well as all the other Azure Monitor integrations you might have for any given resource you're using. Ideally, you are monitoring the same actual channels you would use during an actual outage to ensure you're within acceptable failure bands for your organization. The final element is the chaos experiment itself. This is where we define the set of faults and other actions that you use to simulate the outage or disruption that you're trying to create, and validate your application's resilience against it in a parallel or sequential manner. With these building blocks in place, the best practice that we like to guide customers to do is to first establish a workload baseline to understand how your system behaves under normal traffic and stress, just so you know what to expect and what to know to look for when things are turned back to normal. Then, you would start the chaos and monitor the impact and see if it meets your expectations of how your system will respond to an outage. Finally, an important element that sometimes people forget is when they remove the chaos, making sure that your system actually responds and recovers in the way that you expect and comes back to that steady state that you expect. With all these building blocks in place that we need to do chaos engineering on Azure, that's where Azure Chaos Studio comes in. Azure Chaos Studio provides a validation platform for you to measure, understand, improve, and maintain your product's resilience. What we offer is a managed service for you to validate your Azure infrastructure resilience through our deep Azure integration with the Azure portal, our ARM integration, and Azure Monitor, using our portal UI, REST APIs, and variety of SDKs. We are constantly adding new sets of faults and regions, and our primary goal is to provide the orchestration platform for you to do your fault injection, as well as making sure that all of the right permissions and safeguards are in place for you to not create any more chaos than you want to, and limit the blast radius. We do this through a variety of different products in the platform that help you target different aspects of the cloud stack. Just to show you a little bit about what an experiment might look like when we're designing it, what you'll see is that you'll have a series of steps and branches here. And in these steps and branches, you will see what actions are defined and in what sequence they should occur, and which resources I want them to target for how long. We can add different actions or delays and see the variety of different actions that we offer in our product today. You can also see the monitoring that our product offers. Naturally, you can use monitoring through different products as shown here, as well as being able to export logging via the diagnostic settings to a log analytics workspace. If you simply navigate to any chaos experiment that you're doing and add a diagnostic setting, you can make one for yourself and have it deposit those logs anywhere you like. I'm going to save that setting. Those logs will be available for you in the log analytics workspace, which can then be exported to any of your third-party monitoring tools as well. In terms of disruption types that we support in the Chaos Studio product, we have a variety of different disruptions across the entire Azure cloud stack. The two main disruption types that we offer are focused on infrastructure and platform level faults. And we do this via our virtual machine agent, which is the guest OS option you see here. This is installed in a Windows or Linux VM, and it can run a variety of resource pressure faults such as CPU, memory, disk, network latency, as well as dependency disruption faults, just to name a few. We also have faults where we work directly with the resource provider to disrupt certain services like Service Bus, or Redis, or Cosmos DB, or Azure Kubernetes Service. These are called service direct faults. These are the primary services that we offer in our main product. We also do chaos internally. This is where chaos for infrastructure comes in on bare metal machines below ARM, that the critical services you depend on. Think Azure Storage, networking, and compute, all of which are using Chaos Studio product themselves. We're constantly assisting internal teams in doing a lot of validation because chaos engineering, like I mentioned earlier, is a shared responsibility of Azure and the customer. Hence, we do this on our ends for machines that customers can't access but do depend on. We do also offer chaos for applications as well. This means intercepting Azure SDK or REST API or HTTP calls made from your code and returning a modified output based on your desired experiment. This is all done on the client side, so no actual service level disruption is occurring. This is primarily useful for observing client-side behavior in a low-fidelity way and is in limited preview. In terms of some of the use cases and faults that Chaos Studio offers today, we have a variety of different faults across our agent and service direct offerings. As I mentioned earlier, you can see some of the different scenarios we support today, and we recommend combining these faults together as opposed to thinking about them as individual faults on a per-resource basis. We have, for example, a series of agent faults and some key vault faults, which you might combine to do a virtual machine stress test with an Entra ID outage. So we really try to tell customers to think in terms of scenarios rather than individual faults, thinking about what scenario you're trying to design for infrastructure. Try to frame the problem as, what outage scenario do I care most about? And work from there. From there, you can reason about which faults you really need to create that scenario. If you just visit the link that you see on the screen here at aka.ms/chaosfaults, you can see what we support today, and also let us know if you have any other faults that you would like to see, so we can work with the service teams to enable them. In our product, we have been trying to emphasize this focus on scenarios through our experiment templates, pre-created experiments for common outage scenarios. These are predefined for you to just kind of plug and play your resource into and get started with common customer scenarios. So what are some recommendations for getting started with Chaos Studio? What we really recommend for customers is to take a crawl, walk, run approach. So what does that mean in the context of Chaos Studio? What I mean by that is first exploring and getting familiarized with the product itself, using the Chaos Studio interface, setting up a simple virtual machine, enabling the different kind of faults which we are able to use against it. Something we'll show in our demo today so you can get a feel for running an experiment and what you might expect. After this, you might start to pilot chaos in your own service and see how you might use this for your specific scenario. Perhaps this means trying this in a test environment, making sure that it runs correctly and actually trying to extract from insights from the experiment results. From there, you might scale this experiment up and run it as an organization-wide drill. On that topic, we observe a lot of our mature customers using Chaos Studio to run quarterly drills, where they test the processes of their organization and make sure that they know for sure that everything is meeting all of their SLAs, even under really high system stress scenarios. They also can use these drills for testing the DRIs, or directly responsible individuals' ability to respond to really high-pressure outage scenarios. In the long term, I think a goal for customers should really be to automate this all and get this happening at every level of your development stack via continuous validation. There is no one-size-fits-all in terms of number of chaos experiments or duration of the experiment, but consistency is key. Continuous validation, all the way from when you're checking in code to a test branch, to quarterly drills, making sure that your processes are just as good as your code quality, are how we see people using the product in the long run. I think that's kind of an aspirational state for most Azure customers and what every customer is recommended to do. With all that said, let's go ahead and kick off the actual demo of using the Azure Chaos Studio product to do an availability zone down simulation for virtual machines. So what you see here on the screen is actually the Chaos Studio product page in the Azure portal. Up front, we kind of have some key resources about learning about chaos engineering and how to enable resources and set up an experiment for the first time. In Chaos Studio, the bread and butter resources of our product are the targets, which are essentially how you give permission for Chaos Studio to inject faults into the Azure resources you want for the chaos experiment. As I mentioned, we have a strict permissions model to limit blast radius and maintain safeguards. So we want to make sure that you as the customer are explicitly giving permission to the resources to have faults injected into them. This prevents bad actors from just injecting faults into any resource. The other resource, the chaos experiment, is how we define the sequence of actions that happen during the chaos engineering experiment. What I'm going to do today is basically go through the end-to-end setup of running a chaos experiment, starting with the targets enablement process. So I've already prepped the resources in question here for the purposes of this demo. Since I've already used these resources in the past, I'll actually be able to show you that we can disable these targets as well as enable them, so you can always manage what resources are enabled and disabled for chaos front and center, in case you want to maintain strict permissions around who can do what against any of your given resources. Now you can see that all the resources have been successfully disabled. What we're going to do now is show you how easy it is for us to enable these 3 VMs for a service direct experiment to use our VM shutdown fault. What you see here is we're just going to confirm and enable it quickly. And you can see right here in the top corner that that's being initialized and submitted for deployment. So while that happens, we can see what the definition of the experiment we're going to do is, and Azure will tell us when those targets are ready for us. When you want to actually go ahead and make an experiment, what you're going to do is go to our experiments page and create a new experiment here. When you create an experiment, it's going to ask you for your basics details. Which subscription do you want to use? So we'll use our demo subscription for this right now. What we're going to do today is an availability zone down drill. You can assign your permissions by either using a system or user assigned identity for assigning permissions for what the actual chaos experiment can do. In addition to actually enabling those targets for chaos, which we did previously, you also want to make sure that your experiment has the appropriate permissions to inject the faults right into the right resources. Now we're going to actually design the experiment so you can title these however you want. Here we'll say step 1, take down AZ zone 1. And the branch is going to be taking down VM scale set in zone 1 and so on. And what we'll do is that we're going to add that fault here. What you're going to see on the right is a full list of faults pop up. So what we're going to do here is a VM shutdown fault. In the interest of time, we'll do it for 5 minutes, and we want that to shut down abruptly. But if you don't want it to, that's up to you. After this, we're going to look for the VMs that we want to do this experiment on. So what we're actually going to do is look for the subscription that we want, and here are the 3 VMs that we want. So I could do it and add it like this manually, and they would show up, and I'll show you that in a second. But we could also use the KQL query to do dynamic target selection. And so this is how you can begin to really extract value out of the Chaos Studio product and get scalability in terms of dynamic selection of the different VM instances that you want to select. You can tag those VMs with resource tags based on which ones you want to take down and get really fine-grained with your chaos targeting logic. This is where you really start to get to that advanced level of using the product. But for now, we'll just keep it simple and add the 3 VMs that we want to target with this experiment. So now you'll see in the parameters what actions we are doing, and that's all defined here. And then we can go ahead and create this experiment. we can see that our target enablement is now complete. I had defined this experiment that I wanted to show you prior to this demo for the sake of brevity. So here you can actually see the VM shutdown experiment that I'm going to explain in a little more detail, which is what we're actually going to kick off right now. What we're going to do is shut down this VM in our first zone. Then we're going to do a shutdown in zone 1 and zone 2. And then we're going to do a shutdown in all 3 zones simultaneously. So what we're actually going to be looking at here is the availability across all of these 3 zones and see whether this is going to meet our expectations. Does our system actually start going down? And how much data path availability are we getting across our entire region? And is it meeting our expectations? I also think this will be really interesting to see if our system actually recovers in the end after this high stress scenario. I had already created this experiment, so I'm just going to go ahead and save it and give it a run. What you'll see here is once we kind of start running this experiment, you'll see it enter that pre-processing state. And if you ever drill down into the experiment, you can see each step and what it fails to do or what it succeeds to do. So we'll take a look at an experiment that I already ran in the past to see how it behaved. What you can see here is when the experiment actually kicked off. And what's interesting from this data we're looking at now actually is that you can see that this one right here actually went completely offline. But then the zone recovered much slower than we would have expected. But then you can see that once this kicks off and that the zone starts getting taken down here and the data path availability, which is this line here in the middle, starts to decrease, then we start to see the next zone start to go down. We see this availability really start to decrease a lot at this point. Then finally, when we get to the stage of the experiment where all 3 zones go down, this is when we really see the lowest point of our data availability at sub 10% levels. Then when the experiment finally ends, we see all 3 zones begin to recover. What you're seeing is that the experiment is in action and seeing that your system is recovering as we expected here, which is great to see. It does mean that our data availability did decrease over time, which was expected given the nature of the experiment, and something we would probably want to see building on this experiment is what was the customer experience here? How degraded was it? What latency was the customer experiencing during this time as the data path availability decreased? During this process, as we can see, it kind of starts to decrease before we really see it fully recover. So we can see here that our experiment is running right now. And if we went back to the actual experiment now, and we looked at what was happening right here, we should start to see, and we can start to see it right here at the tail, the availability starting to dip. We can see the experiment starting to take out that virtual machine. This monitoring is actually reading on a minute-by-minute basis. So we have it set to run for a 15-minute total experiment before terminating and returning all target resources to a healthy state. We should expect to observe this again, like we saw in the past, and see that things have progressed over time in the same way as before. So that's the Chaos Studio Virtual Machine Scale Set Zone Down experiment that we wanted to share for Microsoft Build 2024 today. Thanks for joining our session.